All right, so we are continuing working on the application of the Pythagorean theorem, using the Pythagorean theorem in real life. So we have some more distance problems, but this time they're not going to be given to you on a graph. Although it says determine the distance between the following pairs of points, round your answer to tens place, use graph paper if necessary. So if you get stuck, I'm going to draw a sketch here. If you need to, use some graph paper, okay? So what we need to see is where these points are. Okay, and you really don't necessarily need to count them out. You need to make sure you understand where the point is. Here's what I mean. 7, 4, positive 7, positive 4. So we're going to come out here 1, 2, 3, 4, 5, 6, 7, and up 4. 1, 2, 3, 4. And you can see I'm just sketching it, right? That's a 4 right there. Okay. And then we have negative 3, negative 2. So again, this is my x, this is my y. So I'm going to go negative 3, 1, 2, 3, and negative 2. 1, 2. Okay. And we, just like it was on graph paper, we're trying to find the distance between these 2 points. And so we need to sketch a right triangle. Basically what it comes down to for our lengths, well, let me draw the right triangle and let me show you. Okay, this is just like we did the other day. Obviously, my drawing's not the best here, but squint a little bit and we'll be good. This right here is this is the point 7, 4. Okay, so this is 4 units high. Down here, okay, now this point right here is at negative 3, negative 2. This point right here, notice it's still at 7, but it's going to be the same y value as this one. Okay, so basically, we need to see the change in our y's and the change in our x's. I mean, it's totally not finding the slope, but it kind of is the same thing because we're not writing it as a ratio, but we're finding our rise and our run, but we're just not writing it as rise or run. Okay, so if you can see here, if I'm going from negative 2 up here to 4, that's a difference of 6 units, right? Here at negative 2, I go up 1, 2, and then I'm going up 4 more. 1, 2, 3, 4. That's a difference of 6. Now over here, I'm going from negative 3 over to 7. So negative 3 to 7. That would be 3 units to 0. And then 7 units, 1, 2, 3, 4, 5, 6, 7, over here. So if I'm going 7 and 3, that's a difference of 10. Sometimes a visual of it really helps. Some of you can look at this and see that. Like, well, 7 to negative 3, the difference of those, just like I said here. 3 here, 7 here, that's 10. For negative 2, the y difference of 6. The reason those differences are important, remember, is when we use our Pythagorean theorem, those differences end up being our legs, our a and b. Okay, so we can write this as 10 squared plus 6 squared is equal to c squared. 10 times 10 is 100. 6 times 6 is 36. That's 136 equals c squared. Okay. Let's see if I have my calculator here. So let's say I wanted to, of course, take the square root of these, right? Because that's how we undo the square. So my calc is a little different, but if I go 136, take the square root of that, I get 11.6619. It's said to round to the nearest tenth. So I could say C is approximately equal to 11 point, the 6 right here, look at the 6 behind it. That tells us to round the first 6 up to 7. Okay. And round to the nearest tenth place. There we go. So that's the distance between your 2 points. Okay. Now, I'm going to try this time to do it without drawing the picture. Totally draw the picture if you need it, though. Just sketch it. Doesn't have to be perfect. Okay. So I want to start by focusing on my x values, the difference in between this x and this x. Okay. You could just say, negative 5 minus 3, like the absolute value of that. That's distance, right? So that would be equal to the absolute value of negative 8, which is just 8. Or I can think of it as, well, you know what? How many units does it take from negative 5 to get to 0? 5 units. And then from 0 to 3? 3 units. Guess what? That's still 8. Okay? So however you want to think of it. Now, let's look at our y value of 2 and our y value of 6. Okay? If I'm going from 2 to 6, how many units is that? 4. Whether you think of it as 2 minus 6 and the absolute value of that, so absolute value of negative 4 is positive 4, or 6 minus 2, absolute value of 4 is 4. Okay? And so we add 4 squared. And if you're not 100% sure, and again, it's the hypotenuse we're looking for, if you're not sure exactly how that works, sketch a picture, okay? Use graph paper. But again, from negative 5 to 3, that's 8 units. From 2 to 6, that's 4 units. So 8 squared here, 8 times 8 is 64, plus 4 squared, 4 times 4 is 16. That equals c squared. If I add 64 and 16 together, I get 80. That equals c squared. And if I want to know what c is, then we take the square root. Okay? That's 80 right there. So c is equal to the square root of 80. That's the exact answer, but the directions said to find to the nearest tenth. So if I bring my calculator up, the square root of 80. Now again, my calculator might be different than yours. I have to put the square in after. Our scientific calculators, we put the square root in first. Round to the nearest tenth. So I have 8.94427. I look at the 9. So the 9 is in the 10th spot, so I look at the 4 behind it. 4 tells us to keep it at a 9. So this is going to be about 8.9 units. All right. That is just what we were doing in our last lesson, except we're not given the points on the graph now. We actually have to find those distances. All right, I believe one more example here. The old ladder problem. If you've ever dealt with a ladder, right, you are going to prop it up against a wall, okay? Not like the tripod ladders, right? But if you have an old-fashioned ladder, put it against the wall, and that's how you paint or fix things, whatever. But it says, what length of a ladder would you need to reach a height of 7 feet along the wall, where the base of the ladder is 4 feet from the wall? A picture is helpful. So here's my height. The ladder is reaching, here's my wall here, 7 feet up, and it's 4 feet away. What length, like if I had to reach that, how tall does my ladder have to be? Well, notice the wall and the ground are going to hit at a 90-degree angle. Okay, again, you guys find your 90-degree angle, right? Because if you see here, and maybe you're not quite seeing it, but this ladder leaning against a wall forms a right triangle. When you're doing like trellises and roofing or anything, it's not like you're like, hey, I'm building triangles. They form a triangle because this right angle here, this is stable, right? Okay, if it meets at a 90-degree angle, it's going to be nice and firm, and then you can work with the different angles here, the different lengths. So this, nowhere in this did it say use the Pythagorean theorem to find the length of the third side of a triangle. But if you can develop or you can see the right triangle, then we can use our right tool, and we can get a squared plus b squared is equal to c squared. Again, this is going to be c. It's across from the right angle. So 4 squared plus 7 squared is equal to c squared. 4 times 4 is 16, plus 7 times 7 is 49, equals c squared. 16 plus 49 is 65. And we want to know what c is. So I'm going to take the square root, because how do we undo squaring something? Taking the square root. And we get c equals an exact answer of 65. Sorry, kind of freaking out here a little bit. And then if I type that into a calculator, and I think it said around to the nearest tenth. 8.00 is in the 10th spot, so I look at the 6. The 6 tells us to round that up to a 1. So we get an approximate answer of 8.1 feet. All right, so again, the whole purpose of this lesson, we're still using Pythagorean theorem, but the types of problems that are given to us might not be so obvious. It's not saying use the Pythagorean theorem. It's not saying it's a right triangle. But if you can create or see those right triangles, you can use the Pythagorean theorem to solve for missing side length.